So in this video, I will show you how you can write your own um, receiver of data on the Jetson and publish it. So I will assume that you've already gone through the steps to create your own data packet in Broco. So I showed how to do that at the start of the video. And I would also assume that you have the same library on the microcontroller and on the Jetson, so the same version. So I also showed how to do this using the Git submodules and how to update the library so that it can use the same library on the Jetson and on the microcontroller. So there are many different packages that you will need to modify. Actually, all of them almost. So what you will do first is you will need to create a new type of message and a new topic. So let's go first in the avionics config packet. So in the avionics config packet, you will need to create a new topic name. So let's say that I want, in my case, to create a voltage topic. So I just add here the voltage topic and just add here /el/voltage. Okay, so this is the first step to do. Then I will go in where is it? Yeah, the avionics interfaces here, and I will need to create a new message. In my case, if it's for the voltage, here I've created a voltage.message, and this should contain the topic that you want. So in my case, it's the voltage as a float 32. This is because my packet here, if you remember the packet that you've defined in the CAN bus in the protocol 23.h here, if I look for voltmeter packet, you can see that it's a float which only contains the voltage. So in this case, I will just create a float 32 because this is 4 bytes, which contains the voltage. I also add here the ID, which is the ID of the node that the data is sent from. So this is very useful and actually necessary for the multiplexer node to work. So this was the node here, if you remember correctly. Now that you have defined this custom message, you will need to add it here in the CMake list. So you need to add it here in the message files. So in my case, I added it here in the message files. The request are messages for the request and the config for the config. So I might have a separate videos about what these messages are. So just add it here. Afterwards, of course, you will need to build your package. So you just do a colcon build at the root of your package. So you need to do it when you are in EL workspace as the root. So you just do a colcon build. Okay. You can do even a colcon build, then packages select, and then the name of the package, which is avionics interfaces. So you can just write this in the terminal of your root. And then you need to install the package. So you can just write source I if you are on the Jetson, or if you are not on the Jetson, I think you can just do source install setup.bash. So you need to be of course at the root of the folder, which is in EL workspace. So it's you need to be here at this point here. Okay, so once you've done this, you have added your custom message to this package. So the second thing you need to do is to modify the Roco-ROS interface. So first you need to go in the Roco-ROS interface here, and then there is you just need to look at the .h files. So in this package, there is nothing to change. In the publisher, you will need to add your own message to publish. So in my case, it's a voltage. So I just include here avionics interface /message/voltage. So one tricky thing here is that everything is not capitalized. So you just need to make sure that you are using the right names. So for example, the LED response here, you can see that it is defined here as LED all caps then response, but we have to include it as LED_response. So this is the only way for which it can work. So I've added it the voltage message here. So this is something that you have to do. Then you will need to add your publisher. So in my case, it is the voltage pub, which is of type voltage. So this is the message that we've just created. And also you need to add your handle. So this is the callback function that will listen to the code to the CAN bus and will be triggered when it receives a voltage packet. So not a ROS message, but a voltmeter packet that is defined in Broco here. When it detects that a voltmeter packet has been received on the CAN bus, it will trigger the function. So here I have the handle voltmeter packet, and this is the definition of the packet, of the message, of the function, I mean, so with the sender ID and the voltmeter packet pointer here. So this is all you need to do in this package. Okay. Then once you've done this, let's have a look at the subscriber. So in the subscriber, you don't really need to do anything for this because right now I'm showing you how to receive messages from the microcontroller, but the same reasoning can be done if you want to send messages from the Jetson to the microcontroller. So let's do first one way, okay? So now you go, let's go in the Broco Manager. So here you will need to add your new parameter for the topic that we've defined. Okay, so you just add it here. Then I think there's nothing else to do here. So in the Broco publisher here, you need to create your do the definition of your publisher. So it is of type voltage defined in our custom package here. And we just add the prefix. So this is either CAN0 or CAN1. We get the parameter that we've just declared, both in the config file and also loaded here in Broco Manager at the start here. And yes, and we also have to set here the I don't remember what this is, but I think it's the queue size or something. Okay, so you just set the voltage publisher here, and you also need to set the handles. So in my case, it would be the voltmeter packet handle. So here I do a bus handle voltmeter packet, and I give it the callback function that is called when it receives the packet on the bus. So you can just copy paste and change these parameters as well as this function. Okay, let's have a look at the voltmeter packet callback as well, at the voltmeter packet callback. So here, this is the callback. And first what we do is we check if the packet is reliable. So you'll compute the CRC. If it's not reliable, then we just return. And if it is reliable, then we will first create our custom message. So this is the message that we've defined here. Then we need to fill in the fields of our message. So first the ID is given simply by the packet ID. So if you remember, on the microcontroller, the packet was defined as an reliable identifiable packet. So it has, on top of the voltage field, it also has a CRC field here and an ID field. And the ID field corresponds to the dip switch ID that we set here. Okay. So we just set the message ID to packet ID, and we can set the message voltage to the packet voltage in this case, and then we just publish the voltage. So this is very easy, and it's very easy to read also, and makes so there is nothing like complicated in this part. What you have to know is that this node here in Broco Publisher is part of the Roco interface node, Roco ROS interface node. And if you remember from the data flow graph, this is just one of two nodes. So it will actually publish not on the topic that we've defined in the config here. So we defined it as EL voltage. It will not publish on this topic, but it will publish on the topic defined here. So depending on which node we are on, it will publish on either CAN0 or CAN1. Okay. So then we need to have a look at the avionics mux, which is the topic that will choose, the node that will choose the topic. So let's have a look at the mux manager first. So here in the Mux Manager, you will need to actually, do you need to do anything? Yeah, so you need to include your voltage, your new message here, just like before. And another thing that you need to do, of course, is to define your multiplexer. So you can simply do it by adding a multiplexer. In my case here, it's a voltage mux. So I just added here voltage and voltage mux. And that's it for this part. Then in the publisher, there's nothing to do here, as well as the subscriber, there's nothing to do. So now let's go in the muxmanager.cpp. Here you need to add your voltage topic parameter that we've defined before. And you also need to add your multiplexer. So you can just create a multiplexer. And in the multiplexer, you will need to give the topic that you want to publish to. In this case, it will be this topic here. So EL servo rec. It will be not this, but it will be /EL /voltage, right? So this is the voltage topic. This is a line that you need to add in the Mux Manager. And after this, you also need in the destructor of the Mux Manager to delete the voltage mux. So it is here, as you can see, delete this voltage mux. Okay. So there is nothing more to say for this part. Maybe in the Mux publisher here, you need, of course, or maybe it's not very like straightforward, but because we are using templates in C++, you need to define the template. So here we also need to add this line here in the Mux publisher for each type of new message that we make. So this is just for the compiler, so it knows that we have created a Mux publisher with a certain type of data, so that it can adapt and compile for the correct type of data. So here we add a new template class, and we give it here the voltage. So this is the only thing that you need to add in this file. For the Mux subscriber, it's the same thing, but on the other way around, so I won't show it here. So now it should be finished for the Avionics Mux. Now let's have a look at the Avionics config, maybe. I don't think there is anything to do here. I'm just checking to be sure. Yeah, there's nothing to do here. So actually, you are finished now. And if everything goes according to plan, your data will be coming onto the two buses. And depending on whether or not the node is present on the bus, the multiplexer will choose which bus it should choose to publish. So from either CAN 0, CAN 1, and then it will publish on the final topic. So that's it for the publishing side from the microcontroller to the Jetson and through the multiplexer. Okay, so next I will show you how to do that the other way around, so from the Jetson to the microcontroller. Okay, so in this video, or maybe for you it might be like the continuation of the video, I will show you how you can send data from the Jetson to the microcontroller. So I've already shown you how you can send data from the microcontroller to the Jetson, and the inverse is very, very similar in our case. So again, I will assume that you have already set up the libraries on both Jetson, which means that you have already defined the data type that you want to send as a reliable identifiable packet, that you have already recorded and registered this data. So you have already added it to the protocol register here, and that it is also added to the CAN bus here. And so this must be done on both the Jetson and on the microcontroller. So in the start of the video of the protocol communication protocol, I showed you how you can do this on the microcontroller side, for example, then push the code to the library on GitHub, and then update the library on both the Jetson and the microcontroller, so that you can always have the last version of your library. So we'll assume that you have already done that, and that you have already set up your your callback functions on the microcontroller. So I will just show you again in case you haven't done that. If you go inside of system here, and then you go in core, source, telemetry. In the telemetry here, you will need to set up all of the handles, which are the callback functions for a certain type of packet. So in this example, I will show you um, the callback function for the servo packet. So here I've added here a handle on the two buses, so the CAN bus 1 and the CAN bus 2, and I've added the servo packet handle, and this is the function that is called whenever we receive a servo packet. So this is a static function defined in the servo thread here, as you can see. So it's a static function so that we can access it even if the thread, the class thread has not been created yet. Okay, so this is, I will assume that you've already defined this and that this function exists and that it has already been written. So if this is all correct and if you already have the library on both sides, now let's have a look on how you can actually send the data to the microcontroller. So similarly to when I showed you how to send data from the Jetson to the microcontroller, from the microcontroller to the Jetson, you will need to modify quite a few packages. So the first one that you will need to modify is the avionics config. So in the node IDs and the topic names params here, you will need to add your request or whatever you want to send to the microcontroller. In this case, what the topic I'm interested in is the /el/servo request. Okay, so this is the thing that I want to send to the topic on which I will publish to send data to the Jetson, to the microcontroller. I mean, so this is the first thing that we'll add. Then the second thing that you will add is inside of the avionics interfaces. So you will need, oh, sorry about that. So we'll need to add a new message type. So in this case, it will be a servo request. So this is the servo request message. And you will need to add whatever you want to send to the microcontroller. So let's have a look at my implementation. So if I go in STM32 cube, this callback function here is of type servo packet. Okay, and servo packet here, if you go in the protocol 23, you will see that it is defined as channel and angle. So in the Jetson code here on ROS, I will add channel, angle, but I also add the destination ID. So this destination ID here is simply the node ID to which we want to send the data to. So if I send the destination ID is equal to 0, it will automatically choose the correct node. So this will be a hard-coded node. And if we send it 1, then it will go to node number 1. And if we choose 2, it will go to node 2. If we choose 4, it will go to node 4. So this is the goal of having this destination ID, just in case we want to send the message to a specific node. Okay, so once you have added your server request message here, a custom message, you will need, of course, to add it to here, the CMake list. So I just added here to the message request file. So I added it here, message server request. And as usual, when you add a new thing to the custom message, you will need to rebuild the package. So just do a callcon build packages select, and then the name of the package, which is avionics interfaces. So you need to do this in the root of the folder, which is in the electronics workspace folder. Okay. Afterwards, if you are on the Jetson, you can just write source I. This is so it installs everything so that we can use this new message. And if you're not on the Jetson and you haven't set up the shortcut, then I think you can just do source install setup.bash. Okay, so this is the comments that you need to type in the terminal at the root folder. So now that we've added your custom message, there are many things that you need to modify. So let's have a look first at the Roco ROS interface. Okay, so in the Rocoros interface here, you will need first, so we will first look at the H files. So in this file, I think there is nothing to do. Then in the publisher, there's nothing to do because it's a subscriber in this case, because we publish on the topic, it subscribes to that topic and then sends the message to the microcontroller. So here in the subscriber, you will need to add your own subscriber. In this case, it will be a servo request. Okay, so you have your servo request sub, which is described here, and the message type that you just added should be added here on the top. So again, make sure that you follow the following format. So you really have to remove every capitalization and have an underscore between each word for it to work. Okay, so you have added your custom message here, your custom subscriber here, and you will also need to create your own callback function for that subscriber. So in my case, it's the servo request callback, which is defined as follows. So it takes as an argument the custom message that we just created. Okay, now let's go in the brocomanager.cpp. So in this one, you will need to add your parameter here. So it's the servo request topic. So you just add it in the Broco manager, and that's it for this part, I think. Then in the subscriber here, you will need to define your subscriber. So it's the servo, where is it? The servo request sub. So I just create a subscription as a servo request type, and I add here a prefix. So if you remember from the data flow, we will have two subscribers, one on CAN 0 and one on CAN 1, and the Avionics Mux will choose on which topic it should publish so that it can then choose, it can then send the data to the microcontroller depending on if the microcontroller is present on the bus or not. Okay, so you have the prefix here, which corresponds to either CAN 0 or CAN 1. And then we just also have the servo callback here, so that we can call this callback function whenever data is published on the topic. So you just define this part. And then here you will have the servo callback. So it's defined as follows. And what we do is this. So first, what we'll do is we'll first check if the destination ID is equal to 0 or not. If it is equal to 0, we'll set the ID to a default value that we think the message should go to. So this is just depending on our our overall setup. So in the case of the servo, I know that I will be plugging it on the handling device node. Okay, because the servo is at the end of the ARM effector, of the end effector of the ARM. So I know that I want to send it to the handling device node, which is why I have this line here. So this is if the destination ID is equal to 0. And if it's not equal to 0, then we just set the ID of the message to the destination ID that we have here in our message. Okay. Then I just have some information to debug. After this, I need to send the packet to the bus. So what I do is I will simply create here a packet, a Roku packet, which will be sent over on the bus. I then set the channel to the message channel, the angle to the angle. I set the CRC and the ID of the packet. So if you remember, the CRC is the CRC here is computed by a function in Roku, and here the ID is equal to 0 because we are sending from the Jetson. Then I set the destination ID, which was defined here, and afterwards I just send the packet on the CAN bus. Okay. So so this is everything that you need to do here. So this is on the Rocro interface. So it is just one of these nodes here. And after this, there is nothing else to do on this code. So you will now go into the Avionics Mux. So in this case, it should be a Mux subscriber, right? Let's first go in the Mux manager.h. So you will need to add your server request message here, or whatever message you have just added. Then you will need to create your multiplexer. In my case here, it's a servo request mux. So it's here. So it's a mux. It's of type mux subscriber of server request mux. Then so this is in mux manager. Then in the mux subscriber, there is nothing to do here, and here also. Then in the mux manager.cpp, you need to add your server request topic here, and then define your server request. So here in the server request mux, it is a mux subscriber because it is basically multiplexing between two subscribers. So that makes sense because we are going from the Jetson to the microcontroller. So you just need to follow the following format. So you create a new mux subscriber, you give it the type of the ROS message, and then you give it the topic. And here, this argument here is the default node ID to which you want to publish. So as I've said before, because we know that the servo is on the handling device node, then we give it here the node ID is equal to this HD node ID. Okay, then in the destructor, you will need to add here the servo recmux so that we can delete and free the memory when the node dies. So that's it for this part. Then in the mux subscriber, you just need to add your server request template here. And that's it for this part. Okay, so I think it's actually finished. So it was not too complicated. There are only a few lines to change in order to have the whole setup working. And in another video, I will be showing you like the data flow for the config, because I showed you now how to send data from the microcontroller to the Jetson, and then from the Jetson to the microcontroller. And the configuration scheme of our system actually uses the two of these concepts. So the microcontroller will send a message which requests data from the Jetson. The Jetson will send data to the microcontroller after reading a configuration file. Then the microcontroller will configure its data, its configuration, and will send back a response to the Jetson with its current configuration. So it's like a lot of data that is sent in both ways. So I will show you in another video how this works.